Hi everybody, it's me, Dr. V, and I think it's a great day to do some review for your AP Chemistry exam. In this webcast, we're going to talk through free response question number 5 from the 2025 exam. Now, as you may know, this is one of the short free response questions. It's scored out of 4 points. They usually have 2, 3, 4 parts to them, but I want to point out that you really need to keep track of your time during the actual AP exam for doing these questions. So for a short free response question like this one, you should be thinking 8 to 9 minutes. Really not more time than that because you want to make sure you finish all the questions. Before we go any further, grab your calculator, your periodic table, and your formula sheets. If this is the first time you're doing a webcast with me for AP exam review, I really want you to use this time to try the problems on your own. Listen to me introduce each part of the problem, and then pause the webcast, and then write out your own answer, and then resume the webcast and listen to my explanation. That's what's really going to help you develop as a student. The goal here is not just knowing how to answer the questions in terms of the content, but also your strategies in terms of what to write, what not to write, what do you need to make sure you're including so that you get full credit. You want to show off all that chemistry knowledge, but test-taking strategies are a big part of this. Keep track of your score as you go. Did you earn the point? Did you not earn the point? Let's jump right into the problem. Complete Lewis diagrams and some physical properties for compounds X and Y are given. So we have this table here. We have the compound. We have a Lewis diagram for each compound. We have a molar mass and a boiling point. Part A says, based on Vesper theory, predict the geometry around the silicon atom in compound Y. Now, hopefully at this point you've been studying your Vesper geometries. If not, you definitely want to review them. But all you had to write down here was tetrahedral. Now, we know that it's tetrahedral because there are 4 electron domains around the central silicon atom. And there aren't any lone pairs attached to the silicon atom. 4 electron domains, that's tetrahedral. That's what you needed to write for 1 point. You just needed to write tetrahedral. You did not have to give an explanation. The question doesn't ask for one, so don't waste your time writing an explanation where you risk contradicting yourself and not getting credit. A student claims that compound Y has a higher boiling point than that of compound X because compound Y has stronger London dispersion forces. Here's what we need to do. We need to make sure we actually answer the question. We need to make sure that whether we agree or disagree is really easy to find. You kind of want that at the beginning or the top of your answer. We also need to relate our answer to London forces. So the best choice here is to agree. But it's not enough to just say agree. We need to say why we agree. And you have to look at the central atoms. These two structures, X and Y, have very, very similar formulas, right? They're very similar, and the only real difference is the identity of that central atom. Compound X has a carbon in the central atom. Compound Y has a silicon in the central atom. Silicon atoms, though, have more electrons and more occupied energy levels, and therefore a larger, more polarizable electron cloud than carbon atoms. And that word polarizable here is really important. Therefore, compound Y has stronger London forces than compound X has. And that's why compound Y has a higher boiling point than compound X. So agreeing is the way to go. You might actually write the word agree as the last part of what you write, but make it at the top of your answer so it's easy to find. That's what you needed to say for 1 point here. An equimolar mixture of the two compounds is heated. When the mixture reaches 82 degrees Celsius, which compound will have the higher vapor pressure? Justify your answer. So we're talking about how much of it goes into the gas phase. The vapor pressure is the pressure exerted by the particles that have escaped into the gas phase. More particles would be a higher vapor pressure. One thing you want to remember with these kinds of questions is that when a substance reaches its boiling point, that doesn't mean all the particles are going to vaporize instantaneously. Quite the contrary, you have to put the energy in for a while. Keeping that in mind, we know that X has the lower boiling point, and that's telling us of these two compounds, X has weaker intermolecular forces compared to Y, which has slightly stronger intermolecular forces, right? It's got that higher boiling point for Y, so it's stronger attractions between the molecules. That means that compound X is going to have the higher vapor pressure. Why? Well, compound X has those weaker IMFs. We don't even have to specify what IMFs we're dealing with here. They're weaker, and therefore it's going to take less energy for molecules of X to escape into the gas phase, which means more molecules of compound X are going to escape into the gas phase and therefore exert a higher vapor pressure. Right, since more molecules of compound X are going to vaporize at 82 degrees Celsius than compound Y, we're going to have that higher vapor pressure for X. There's another way you could answer this question. You could say at 82 degrees, compound X has reached its boiling point, and so it will start to vaporize. But compound Y has not reached its boiling point yet. It's still a liquid, and very few particles of Y are going to end up in the gas phase. And so more molecules of compound X are going to vaporize at these conditions compared to compound Y. You needed to have one of these two sets of answers in order to earn the point for part C. And the question continues. The mixture is heated to 198 degrees Celsius in a sealed, rigid 12.5 liter container, at which point both substances are gases, and the total pressure in the container is 2.30 atmospheres. Calculate the number of moles of gas particles in the container. So let's think about what we know. Listing your knowns is always a good idea. We're given that the volume is 12.5 liters, that the pressure is 2.30 atmospheres. We're given a temperature in degrees Celsius. I'm going to go ahead and convert that straight into Kelvin. We need to solve for moles, so that tells me the ideal gas law is the equation that I want, and I can rearrange it to solve for moles, or N, and that would give me PV over RT. We do want to make sure that we use the appropriate R value. I have a pressure in atmospheres. I want to use an R value that involves atmospheres. So that's the 0.08206 liters times atmospheres per mole per Kelvin. If I don't use the right value for R, I'm not going to get the right answer. I can then substitute and evaluate because I know everything to put in. I know PV, R, and T. I can put those numbers in, and I get an answer of 0.744 moles. I do report my answer with 3 sig figs. This question wasn't scored on sig figs in 2025, but you should always be paying attention to sig figs in your calculations because you don't know which question is going to be scored on sig figs in the free response. That's what you needed to do to earn 1 point. As a reminder, you need to make sure you show your work or your setup for any calculation, even simple ones where all you're doing is adding and subtracting. I also want to point out that including the units in your setup helps to avoid errors, right? If you look at my setup here, atmospheres and liters and Kelvin all cancel out, leaving me with moles. If I had used the wrong value of R with wrong units, they wouldn't cancel out appropriately, and that would be a really nice clue that something wasn't right in my setup. How did you do? Well, like we said earlier, this was a question scored out of 4 points, and the average score in 2025 on question 5 was 1.88 points out of 4. Students did pretty well. So if you scored 2 points, you're in good shape. 3 or 4 points, you're doing really well. Keep on studying because there's always room for improvement. If you found this webcast to be helpful, like the video and leave a comment, and subscribe to my channel so you get all my latest updates. Take care and keep studying chemistry every day. That's the key to success.